Hello guys, welcome to the channel. So we have got a really interesting problem today, which is merge without extra space. The problem is asked by companies like Microsoft, Adobe, etc. And in this video, I'm going to explain everything related to this problem. So let's start with the problem statement. It says that you are given two sorted arrays, array 1 and array 2 of sizes n and m in non-decreasing order. Your task is to merge them in sorted order without using any extra space. And you can modify array 1 so that it contains the first n elements and modify array 2 so that it contains the last m elements. Now let me explain the problem with this example. So we are given two arrays, right? The first array contains 1, 3, 5, 7, and the second array contains 0, 2, 6, 8, 9. Now, if I write the sorted order after merging the arrays, then I will have 0, 1, 2, 3, 5, 6, 7, 8, 9, right? Now what I can do is I can assign the first n elements to the array 1 and then last m elements to the array 2. This way I will have 0, 1, 2, 3 for array 1 and then 5, 6, 7, 8, 9 for array 2, right? This is array 2 and this is array 1. So this is going to be the output. Now I hope you have understood the problem statement. So let's talk about the solution now. Okay, so here I have written the same example as given in the problem statement. And the first approach that will come to your mind is quite similar to this one. What you can do is, first of all, you can merge the arrays and then write the sorted order, right? And after this, you can simply assign the first n element to array 1 and then the last n element to array 2. But the problem with this approach is I'm using some extra space in order to store the sorted elements, right? But we don't have to use the extra space according to the problem because it says that merge without extra space, right? And how we can solve this problem then? Let's see. Okay, so here what I can do is I can observe one thing from the problem statement. The thing is, after merging the elements and assigning the values, I will have all the smaller values in the array 1, right? And all the greater values in the array 2. All the greater values in the array 2. So even you can see from the problem statement only, you can see here that I have all the smaller values here and greater values here, right? Now I want you to observe one thing, that if I point to these two values, which are the first two values, and this is the smallest value of array 1, this is the smallest value of array 2, right? And you can see that the first value of array 2 is smaller than even the smallest value of array 1. This means that this value, which is 0, should be the part of array 1, right? So what I can do is I can write this 0, let's say here. Now you can see that the size of this particular array, which is array 1, is greater than expected. The expected size of this array is 4, right? But now the size is 7. This means that I have to remove some element from this array. I have to remove one extra element from this array. So what element I should remove? The answer is this 7. Why this 7? This is the question. 7, because you can see that 7 is the greatest element of all these, right? And greatest element should be the part of this particular element, right? Because I have got first 4 smaller element here. Fine. So this particular operation is similar to swapping these two values. So when I swap these two values, then I will have 1 3 5 0, and in the array 2 I will have 7 2 6 8 9, right? After this, my greatest element is this one, right? And now you can see that I'm done with these two elements, right? So what I can do is I can move okay, so 0 was here, so now I can move this pointer and this pointer is now pointing to this value, right? Can I write the pseudocode along with writing the approach? Of course I can do this, but before doing this, let me move this particular stuff aside, right? So I'm going to move this particular thing here. Now let me write the pseudocode at this place, right? So you can see that I have, let's say this pointer is I and this pointer is j, and this particular pointer, which is pointing to the greatest value that I need to remove each time, is let's say k, right? So you can see that if my array 2 of j is smaller than array 1 of I, so this case is if my array 1 of I, you can see that this is smaller than array 2 of j, right? Array 2 of j. What to do in that case? In this particular case, I need to swap the value at k and j, right? So what I'll do is I'll simply swap values at array of k, array 1 of k and array 2 of j, because array 2 of j should be present in array 1. That's why I am doing this operation, right? And just after this I can remove I can move the pointer which is pointing to largest value. Now this is the largest value, you can see here. So I'll do k minus minus, and just after this I'll do like j plus plus. Because I'm done with this particular element, so I'm going to increase the j pointer. Now j is pointing to this and I is pointing to the same element, right? Out of these two elements, again you can see that this one is smaller, right? And if this element is smaller, this is a part of else case, right? So if this element is smaller, then you can see that this is already in the array 1, right? This is already in the array 1 where it should be. So I have to move I pointer without any swap here. So I can simply do I plus plus here, right? Once you have understood this thing, then you can like complete all the function. Now what you will do is you will check out of these two. Out of these two, 2 is smaller, right? So I'm going to swap this 2 with this 5. This way I will have 1 3 2 0 here, and below this I will have 7. Okay, after this 5, then 6 8 9, right? So now you can see that what I have done here is I have k here, right? I have k here, and now k is going to increase, k is going to decrease. So once k is decreased, so you can see that both are pointing to same position, like I and k are pointing to same position, right? So at this position I'll write I have to stop. I have to stop, and you can see that I have got all the smaller element on the top and all the greater element on like the below array 2, right? So let me write the condition here. While I is greater than equal to k and j is smaller than n, right? Okay, I is smaller than, I think I should write here smaller than. Let me write, this is the condition, this is the condition. And one more thing is, when I is equal to k, then again there is a possibility that the element at I and element at j is something which is like element j is smaller, right? But here it is not smaller, so I am going to increase I, and now I is here and k is here, so my loop is going to stop at this position, right? So once you have understood this particular loop, then all you need to do is you need to sort the arrays. Now you can see that I've got all the smaller element on array 1, so I can sort this array, and once I sort this array, then I will have 0 1 2 3, right? Similarly, if I sort array 2, then I will have 5 6 7 8 9, and this is going to be the output. So once I have got all the smaller element on the array 1 and all the greater element on array 2, then I can sort both the arrays. Now what I'll do is I'll remove this particular part, and here I need to write like I need to assign the values to the pointer. So I is going to be equal to 0 first, I is equal to 0, then j is equal to 0, right? And after this my k is equal to last element of array 1, right? This is n minus 1. So this is how we can solve the problem. At last we need to sort the array. So array 1 dot sort, and then array 2 dot sort, right? Now let me show you the code for this. The code is going to be exactly the same as I have explained here. So you can see that I have the Java code here, and then I have the C++ code here. You can see that first I am performing the operation, then I am sorting both the arrays, right? And this is the Python code that we have. So what is the time complexity of this code? Let's discuss the complexity. So you can see that first of all I am performing operation which is O of m plus n, right? And after this I am sorting both the arrays. So the complexity will be O of n log n plus O of like m log m, right? So this is the time complexity for this approach. And we know that whenever we have a complexity of n log n, then the like input size that we have is going to be 10 raised to the power 5 at max, right? We can't have greater than this particular input size. So this is the problem with this approach. This is the problem. Of course it's going to be accepted for the given problem, but we are going to do some optimizations for this like solution, right? And even this is the reason, this is the reason why this problem is tagged as a hard problem, right? I'm going to tell you a very interesting approach which is going to reduce the complexity from O of n log n plus m log m to O of m plus n. and I think this is a linear time complexity, right? And this is going to work for input side 10 raised to the power 8, right? So now let me talk about the second approach that we have. Okay, so here I have written the same like example as given in the problem statement, and I have like kept the separate space for the pseudocode, right? Now, before I talk about the approach, I want to talk about, I want you to recall about merge sort technique to sort the array, right? In this technique, what we do is, let me take an example to explain. So let's say I have 3 1 2 7 5. I have this array, right? So in merge sort we keep dividing the array, this is a kind of divide and conquer approach. So I will have 3 1 2 here, and then I will have 7 5 here, right? And after this we keep dividing the array till we get the sorted array, right? And once this array is sorted, let's say now this array is sorted and this is 1 2 3 and this is 5 7, right? So after this, the operation that we perform is merge operation, and we merge these two arrays into a sorted array. So now there is one thing to notice here. The thing is, we have two sorted arrays here, right? And we have to merge them into a single array. So this problem, like this particular operation, is quite similar to the problem which is given to us. We have to merge two arrays, right, which are sorted. So we can use the same concept of merge sort in order to like solve the given problem. Let's see how. The only problem with this operation is we use some extra space, right? So now first of all, let me remove all the like stuff from this page, and now I'm going to talk about merge function. In the merge function, what we have is we have two arrays. So let's say the same example, I have 1 3 5 7, then I have, okay, so I have 0 2 6 8 9, right? Now I'll have two pointers, this is I and this is j, and I will have one more list which is going to have a pointer k here, right? So out of these two, which value is smaller? Let me ask from you, which value is smaller? So you can see that 0 is smaller, right, which is array 2 of j. So I'll write 0 here and then I'll increase the index k. So this is how I'm going to move. Let me write here. So if array 2 of j is smaller than array 1 of I, in this case I'm simply going to put like answer of k equals to like array 2 of j, right? Array 2 of j. This is how we solve in merge function. So after this I'm going to do k plus plus, and along with this I have to do j plus plus as well, right? Because now j is going to point to array size 2, like this particular element. So I will do j plus plus. Similarly, if let's say my array 1 of I is smaller, so in this case I'll say that, okay, now my answer is going to be array 1 of I, right? And then k plus plus and then I plus plus. So if I move further, then you can see that now this element is smaller, so I'll write 1 here, then again I'll increase the index k and I'll increase the index I as well, right? Now out of these two, 2 is smaller, so I'll write 2 here, then I'll increase the index j and then I'll increase the index k as well, right? After this, you can see that out of 3 and 6, 3 is smaller, so I'll write 3 here, then I'll again increase the index. This is how we move in merge function of merge sort, right? We can use the similar approach to solve our problem. Let's see how. First of all, let's see the problem that we are facing, like in this approach. In this approach, the problem is I'm using some extra space here, right? I'm using some extra space to store the answer. You can see that I have answer of I. But what I can do is I can modify the same array in order to get the sorted items. Like, what if I have the ability to store, okay, so before talking about like this thing, let me remove all the stuff first. So I'm going to write the same example again. I have like 0, then 1, then 3, and then 5, right? And I have, okay, so I have, let me remove this, I have written wrong here. I have to write 1 3 5 7, and after this I have to write 0 2 6 8 9, right? So now I have two pointers, you can see here, and I have I here, then this is j, and then you can see that array of j is smaller, array 2 of j, right? Array 2 of j. So I have to, the actual position of this 0 should be here, right? I have to store this value at this index, which is k. But how to store? We already have one value here, right? And this value I want to perform the further operation with this value. So I can store 0 and 1 at the same time at the same index. How we can do this? How we can do this? So once we are able to store this value, then you can see that I can store something like this, right? And after this I'll move here, like this j will move here, then I'll write 1 here. So you can see that I'm getting the sorted manner by doing this. So now the question is how to store two values at the same index. This is the question. But before talking about this, let me remove. So I'll write, the question is how to store two values at same index. This concept is really important, guys, and used in a lot of problems. So I want you to learn this particular concept. Once you know this concept, then you will be able to understand like this particular solution, and it's really going to be a cupcake for you to understand this. Let's see how. First of all, let me take a value which is 5 in the array, right? So after this, let's say I want to store one more value here, which is x equals to 7. So I want to store 7 at this place, right? In order to achieve this, I need to take one more value. So let's call it mod. And the value of this mod is going to be, let's say I have 10, right? So how I can store this value? I can store two values at the same index by using the Euclidean division lemma. Euclidean division lemma. This particular algorithm says that any dividend d is equal to divisor into quotient plus remainder, right? So once we have this dividend, then we can get the quotient and remainder both. Let's see how we can get these. So we are going to do an operation which is array of I is equal to let's say which is x into mod plus array of I. And when I perform this operation on this value, this is array of I, right? So when I perform the operation on this value, then I will get 7 into 10, which is 70, plus 5, which is 75, right? And now you can see that I have stored two values at this position. How? From this 75, if I want to get the value 5, if I want to get the value 5, which is the original value, right? So original value will be 75 divided by mod, which is 10, right, divided by mod. This is going to give me, okay, 75 mod, right? This is going to give me 5. So this is the original value that I have, and if I perform 75 divided by mod, this will give me 7. This is the value that I have stored, right? So let me generalize this particular thing. I can generalize this thing. Once you guys know this particular formula, once you guys are aware of this particular formula, then you can write that original value is going to be equal to array of I mod, right? This is going to give me the value 5 when I perform on 75, right? And the stored value is going to be array of I divided by mod, right? And when I say divided by, then I'm actually talking about the integer division, right? Okay, now one more thing is how to know that this value, let's say the value 75 is stored here now, right? So how to detect or determine whether the value is modified or not? So it's original value which was stored or the modified value. It's quite simple to like determine this thing. What I can do is I can compare with mod value. If array of I, which is this file value, is greater than equal to mod, right? In that case I can say that the value is modified. But there is one condition in order before checking this particular thing. Make sure that the mod value is greater than the maximum value that this array can have, right? For example, for the given problem, we can not have any element which is greater than 10 raised to the power 5, right? So we can take the mod value as 10 raised to the power 5 plus 1 or 10 raised to the power 6, any value, right? Or even we can take most commonly taken value, which is 10 raised to the power 9 plus 7. So we can take even this value as the mod value because this is the maximum value, right? So once you have understood this particular concept, so you guys know that how we can store same value like two values at the same index. Now let's talk about the approach. I am going to have two pointers, so I will have I here, then I will have j here, right? And one more pointer is going to point to the starting values. Okay, now I know that out of these two value, like this value is smaller, right? Values at array j is smaller. So I'll check if my array 1 of I is greater than array 2 of j. This means that this particular value is smaller, right? So I need to store the value 0 at this particular place. How to store? I already have one value, right? And I have the mod value as 10 raised to the power 9 plus 7, right? So I'm going to store two values here by doing array 1 of k equals to I'll do, okay, I have to write array 2 of j into mod plus array 1 of k, right? This is the same operation that I have explained you here. You can see that the same operation I am applying here, right? So now this is what I will do. After this, I'll increase the value of k and I'll increase the value of j as well. So once you have done this, then now the pointer j is pointing to this value and the pointer k is pointing to this value, right? And here at this index, I have the value stored, which is 0, 1. I hope you are able to understand this particular thing. After this, now again, I will check these two values, right? And before checking these two values, see here, we have stored two values here, right? This means that this particular value is modified. So I have to make sure that the value is modified before like directly grabbing. I can't like get the original value by doing simply this if the value is modified. I have to do array 1 of I mod, right? If the value is modified. So before directly checking these two values, I have to check whether the values are modified or not. So how I will check these? Let me change the color because now I am going to talk about the pseudocode. If like array 1 of I is greater than equal to mod, this is how we check modified. I've already explained this particular thing here, right? And array 2 of I like array 2 of j is greater than equal to mod. This means that both value array of I and array 1 of I and array 2 of j both are modified, right? Both are modified. So I will take like the action accordingly. I perform the operation accordingly. After this, the second possibility is like array 1 of I is modified, right? And the third possibility is like array 2 of j is modified, right? And the fourth possibility is simply and no any value is modified, right? This is the fourth possibility. And when we have fourth possibility like no value is modified, then we can simply do this particular thing, right? And what is the else condition here? So else condition is simply like, okay, let me remove this particular thing because I have to change the color now. This is the first condition when array 1 of I is like greater, and if my array 2 of j is greater, in that case I will store array 2 of like array 1 of I instead of array 2 of j, right? So I'll write array 1 of k equals to array 1 of I cross mod plus array 1 of k. This is what I will do, and after this I'll do k plus plus and I'll do j plus plus, right? Okay, I plus plus here. So this is what I will do for else condition. Here you can see that I'm not using like any extra operation to extract these values. I can simply get the values by doing writing this, right? But when we have both the values modified, then we will modify this particular code. I will write here if array 1 of I mod. This is how I will be able to get the original value from this, right? You can see that this is how I will get the original value. Once I got the original value, then I'll check if this value is like greater than array 2 of j, again mod, right? If this value is greater than array 2 of j, in that case like, okay, there is else condition as well. In that case what I'll do is I'll store like this particular like array 2 of j here, right? Array 2 of j in place of k. So I'll write array 2 of j is okay, let me remove this. I have written wrong here. Let me remove this thing. So I have to write array 1 of k, array 1 of k equals to array 2 of j mod, right? After this I'll multiply this value by mod, and then I will add array 1 of k. This is how I will store, and after this I'll do k plus plus, then I will do like j plus plus, right? So this is the concept, this is the basic concept behind the like approach. I'm not going to write the whole code. Instead of this, I'll write like I will explain you the approach, and after this I will show the implementation. Okay, so now what I'll do is let me remove this particular stuff, right? Let me remove this particular stuff, because I think you have understood this thing. And now I'll write here, I will try to explain the approach further, right? So after this, my j is here, right? And you can see that out of these two values, this value is smaller. So I'll store this value at the position k. So after this, I'll have 1 and 3 here, right? Again, I have to take the red color, right? I have to take the red color, so I will write 1 and 3 here. Now after this, my I pointer is going to increase. My I pointer is now pointing to this value, and my k is also going to increase. K is pointing to this value, right? And after this, I'll check the value at I and j. You can see that I have 3 and 2, right? And 2 is smaller here. So I'll store 2 at the position k. So I'll have 2 and 5 here, right? After this, my j is going to increase. So my j is now pointing to this value. And after this, if I compare these two values, okay, k is also going to increase before that. After this, I'll compare 3 and 6, right? And out of these two, you can see that 3 is smaller, so I'll store 3 here. So at the position k, I'll store 3, right? Now k is going to increase, and you can see that k is now out of bound, like out of bound for array 2. So I'm done with array 2. Now array 2 is basically storing the value 0 1, after this 1 3, after this 2 and 5, after this 3 and 7, right? I have the stored value as the answer. I have the stored value as the answer. So how I can get the answer from this particular array? I can simply divide the array by mod. If I divide the array by mod, then I will have all the value like 0 1 2 3, right? But before grabbing all the values, before like taking all the value from this array, I have to do the same operation for the array 2 as well, right? I have to do the same operation for the array 2 as well. And from which point we are going to start? You can see that after performing this operation, after performing this particular operation, my j is pointing to this 6 and my I is pointing to this 5, right? So I'm going to start from these positions only. You can see that I'm done with these four elements like 0 3, then like 1 3 0 2, right? And now I'm only left with these particular elements. So I have to start from j and k, like I and j, these two positions. And one more thing is I have to reset the value of k. Now k is pointing to this particular place, right? So this is how I'm going to move. And when I perform the same operation for this particular array, then I will have here I will have 5 and 0 first. After this, I will have 6 and 2. After this, I will have 7 and 6. After this, I will have 8 and 8, right? And then 9 and 9. Quite simple. So now you can see that both the arrays are storing the like answer. But all I need to do is I need to divide all the elements by mod. So when I divide all the elements by mod, then I will have the stored value in the arrays. And you can see that how we get the stored value by dividing simply. So at the end I will have 0 1 2 3 for the first array, and then I will have 5 6 7 8 9, right, for the second array. This is how we can solve the problem. And what is the like complexity of this approach? We are only iterating one for this array, this is m plus n, right? And then we are iterating in this array, this is m plus n, right? So this is how we can solve the problem. Now let me show you the code, and I'm going to explain the code in detail because I have not written the pseudocode well, right? So just make sure that you understand the code, you see the code carefully, I mean. Okay, so you can see that I have I, j, k and s0, and for this I have like mod value as 10 like 10 raised to the power 7 plus 1, right? Because 10 raised to the power 6 is the maximum value that we may have. Okay, now you can see that how I'm checking the values. Let me make it clear. It's quite lengthy code, but first of all you can see that this is the condition where I have both the values modified, like array 1 of j and array 2 of k, right? Okay, so let me explain the pointers assignment for this particular approach. Here I have written the like something different pointer assignment, but the actual pointer assignment is I is going to play the role of k here. So I have I which is going to iterate over all the values, and then j is pointing to the current value of array 1 and k is pointing to the current value of array 2, right? I hope you have understood this thing. So now coming back to the code, you can see that I'm comparing the values array of like array 1 of j and array 2 of k, and you can see that both values are modified. So I'm using a mod operator to extract the original value, right? And after this I'm storing the value. You can see that plus equals to means the same, like I'm adding the value of array of I, right? After this I'm doing j plus plus, and after this I have here for like else condition I'm storing the value of array 2 of k, and then I'm doing k plus plus. After this the second condition is if only array 1 of j is modified, right? In that case I'll do something like this. The operation is exactly the same, the only difference is now I'm not using mod operator for this one, right? The concept is going to remain same for every condition. Like here you can see that I have array of 2 modified, right? So in this case I'm checking whether array of 2 is like I'm not taking any mod operator for array 1, right? Array 1 of j. And for the last condition, if no any value is modified, then I'm simply getting the values without any mod operator, right? Okay, now after this, as we do in merge sort, like in merge sort we check the remaining element by this condition, right? Once we have like or I or j have reached the boundary condition. After this, this particular code is for the first array, which is array 1. After this I need to reset the pointer, and I'm resetting the I pointer, right? Because I pointer is pointing to the answer, and now I'm doing the same operation, exactly same operation for the array 2, right? If you check this particular loop and the previous loop, then everything is same. The only difference is now I'm storing the value in array 2, right? You can see here now I'm storing the value in array 2. Once I have done both the operation, then all I need to do is I need to divide every value, like okay, this is for the merge sort condition, and at last I need to divide every value in array 1 and array 2 by mod. This is going to give me the stored answer from the two values which are stored in the array, right? So this is all about this problem. Now let me show you the same code for the C++. This is the code, right? You can see here that I'm writing, okay, Java and C++ code is exactly the same. The only difference is the function name, right? The only difference is function name. And now talking about the like Python code. So Python code is again, the concept is going to remain same. The only difference is of concept, right? So this is all about this video. I hope you guys will like the explanation. Thank you.